Okay, let's unpack this. You're sitting at your computer, right?
Yeah.
Staring at a login screen. And you realize you have absolutely no idea what your password is.
Oh, yeah, the classic mind blank.
Right. Or, you walk into a room to grab something, and the exact moment you cross the threshold, your mind just wipes itself completely blank.
It is honestly the most frustrating feeling.
It really is.
Yeah.
Usually when that happens to you, the immediate reaction is just pure frustration. You feel like your brain just dropped the ball, like it's a glitch in the system.
Right, because we tend to expect our minds to function like a perfectly organized, infinite hard drive.
Exactly.
And when we reach for a file and it just isn't there, we immediately assume the hardware is breaking down.
Mm-hmm.
But the source material we are looking at today argues the exact opposite.
Yeah, and that is the mission of our deep dives today. We are pulling from this incredibly fascinating Substack article by an author known as SpiralSeekr.
Such a great piece.
It really is. It's titled The Physics of Forgetting and the Endocannabinoid System. And we're basically going to explore why your brain is actually biologically hardwired to delete information.
Yeah, deliberately deleted.
Right. We'll look at the hidden neurochemicals that act as a sort of garbage disposal for your memories. And ultimately, we're going to dive into the really alarming implications of what happens when we mix our ancient, biologically forgetful minds with a modern digital world that literally never forgets a single thing.
Which is a huge collision. Yeah. SpiralSeekr sits at this really fascinating intersection of technology, biology, and philosophy.
Yeah.
And the core argument here challenges the entire foundation of how modern neurobiology usually talks about memory. Like, we are usually so obsessed with how to acquire more memories. Right?
Oh, totally. Brain games, memory hacks, all of that.
Exactly. How to retain more data, how to optimize recall. The core assumption is always that remembering is the ultimate biological goal.
But I can promise you, by the end of this conversation, you will completely rethink your relationship with your own memory.
Yeah, absolutely.
And more importantly, you're going to look at the smartphone sitting in your pocket right now in a completely different light.
You really will.
So to understand why your brain so desperately needs to forget things, we have to start with the shocking physical reality of what a memory actually is.
Right, because we use words like cloud or, files.
Yeah, it makes memory sound like this ethereal, weightless ghost in the machine, like a little, I don't know, a little movie projector playing in the theater of your mind.
Which sounds very poetic, but biologically, it could not be further from the truth.
Not at all.
The source material establishes a crucial baseline right out of the gate. Memory is not a floating concept. It is a dense, highly physical entity.
This is the part that blew my mind.
Yeah, every single time you encode a new experience, your brain literally goes under construction. It is building microscopic physical structures called dendritic spines.
Okay, I want to make sure we are visualizing this correctly because it's a wild concept.
It really is.
These dendritic spines are actual physical protrusions growing on the branches of your neurons.
Exactly. They're physical matter.
So your brain is laying down literal biological infrastructure every single time you learn a new fact or, experience a new event.
Think of them as the microscopic scaffolding, where neurons physically connect and communicate with each other.
Wow.
So to hold onto a memory, your brain alters its own physical architecture. But building and maintaining infrastructure comes with a steep cost.
Like any construction project.
Exactly. Here is the physical reality that SpiralSeekr focuses on. Maintaining these synaptic clusters across a human lifetime demands a massive, continuous expenditure of energy.
Right.
Specifically adenosine triphosphate, or ATP.
And ATP is basically the cellular battery power of the body, right?
Yes, exactly.
You have to continuously pay a biological toll just to keep the lights on for that specific neural pathway.
Just to keep it alive.
And the article calls this a staggering metabolic burden.
Because your body operates on a strict energy budget.
Right, there's only so much to go around.
Exactly. So if you are trying to maintain the physical metabolic infrastructure for every single memory, like every mundane conversation, the exact pattern of a rug you saw in a waiting room 10 years ago.
Which you don't need.
You really don't. The energy cost of keeping all that alive becomes astronomically unsustainable.
That makes absolute sense if we look at it through the lens of evolutionary survival.
Absolutely.
Because the source points out that human survival relies on internal predictive modeling software. Like your brain's primary job is to look at past experiences and predict what is going to happen next.
Right, so you don't get eaten by a predator or so you can find food.
Exactly. But if your internal data set is bogged down with all those irrelevant, noisy details like that waiting room rug, the predictive modeling simply buckles under the weight of it.
You cannot extract what the author calls actionable, probabilistic signals.
Actionable signals, right.
You lose the ability to find the vital signal in an ocean of noise.
Okay, let's make this really visceral for you, the listener, because it is so counterintuitive to how we usually think about intelligence.
Yeah, analogies help a lot here.
So imagine you have a smartphone, but the operating system has a fatal flaw. It forces every single app you have ever downloaded, every photo you have ever taken, and every web page you've ever visited to run in the background.
All at the same time.
Simultaneously. Forever. It's not just a storage space issue. The battery would drain in like 3 minutes.
Oh, easily.
And the phone physically overheats to the point where it burns a hole in your pocket. The processor slows to an absolute crawl until the phone just, bricks itself.
That burning battery is your brain's ATP. Memory decay is the brain aggressively managing its power draw.
Wow. Memory decay is aggressive power management. I love that.
What's fascinating here is that active synaptic pruning is not a failure of our neuroarchitecture. It is a highly optimized, beautifully designed thermodynamic necessity.
So forgetting is a feature, not a bug.
100%. The degradation of memory, the actual physical deletion of data, is the exact mechanism that prevents a catastrophic system crash.
That makes so much sense.
A computational framework that only writes data without ever executing a deletion protocol inevitably collapses under its own structural entropy.
Meaning a mind that isn't actively clearing out the junk eventually just drowns in its own internal chaos.
Exactly.
So, okay, if forgetting is a strict metabolic requirement to keep our biological batteries from overheating, the obvious mystery is how the brain actually executes this delete command.
Right, the mechanism.
Because if you delete the wrong file, you forget how to walk or how to identify a threat. How does the system target the trash without burning down the whole house?
That requires a highly specialized chemical mechanism. And the article identifies the star player in this process, which is the Endocannabinoid System, or the ECS.
The ECS, right.
It functions as the brain's primary retroactive inhibitor.
Now, when you hear the word cannabinoid, your mind probably jumps straight to cannabis.
Which is fair.
Yeah, which makes sense given the name. But the endo part of endocannabinoid means this is a system naturally occurring within your own body. It is your internal architecture.
It is entirely endogenous. Specifically, the source highlights a critical endogenous ligand called anandamide.
Anandamide.
Right. Now, just to break down that terminology real quick, a ligand is essentially a biological key designed to fit into a very specific receptor lock in your body.
Okay.
Anandamide is the chemical key.
Got it. And it's often referred to in pop science as the bliss molecule, right?
Yeah.
Drawing from the Sanskrit word for joy.
It is, yeah.
But in the context of memory and structural entropy, it is doing some incredibly heavy, targeted lifting. It's not just about bliss.
Not at all. The way anandamide operates breaks the traditional rules of neuroscience.
How so?
Well, typically neurocommunication is a one-way street. A presynaptic neuron sends a chemical messenger forward across a microscopic gap to a postsynaptic neuron.
Okay, so the signal travels down the line, forward.
Right. Anandamide, however, utilizes something called retrograde signaling. It moves in reverse.
See, here's where it gets really interesting.
Oh, yeah.
Because thinking of a brain signal going backwards feels like water flowing up a waterfall, but it is brilliant.
It's totally counterintuitive.
It is. Let's picture this retrograde signaling. Imagine a massive, chaotic nightclub.
Okay, I'm with you.
The DJ is blasting music, the crowd is going wild, and the party is completely out of hand, basically draining all the electricity in the building.
Burning up all that ATP.
Exactly. So the normal flow of traffic is people walking into the club, moving forward toward the dance floor. But anandamide is like a bouncer stationed all the way at the exit doors.
Right at the back.
Right. And instead of managing the people leaving, this bouncer turns around, walks backwards through the dense, chaotic crowd, goes all the way up to the DJ booth, and aggressively unplugs the speakers to shut the music off at the source.
That captures the dynamic perfectly. The bouncer goes against the flow of traffic to stop the signal from originating in the first place.
Oh, that's so cool.
It is. The postsynaptic neuron releases anandamide. It travels backwards across the synapse, and it binds to specific locks called CB1 receptors on the sending neuron.
Okay.
And when that key turns the lock, It inhibits the release of excitatory neurotransmitters. It unplugs the DJ.
But shutting off the music is just a chemical signal, right? How does unplugging the DJ actually lead to the physical deletion of a memory?
Ah, that's the key question.
Because we established earlier that memories are physical structures, those dendritic spines.
Right, that bridges the gap between the chemical and the physical.
Yeah.
You see, the brain operates on a ruthless, use it or lose it metabolic principle.
Very ruthless.
Very. When anandamide travels backwards and stops the signal, that specific neural pathway stops firing.
Okay.
And because it is no longer firing, the brain stops sending precious ATP energy to maintain it.
Oh, so it literally starves the memory.
Yes,
Yeah.
exactly. Without ATP, the physical dendritic spine withers. It dissolves and is literally reabsorbed by the body. The infrastructure is dismantled because it is no longer being used.
So, using the analogy, the club goes bankrupt and the building gets torn down to make room for something else.
Exactly.
That is an incredible biological sequence. And the source explains why this specific mechanism is so critical for our sanity.
Extremely critical.
Particularly when it comes to trauma or outdated behavioral loops. Like, imagine you developed a really defensive, anxious reaction to a volatile environment as a child.
Right, a coping mechanism.
Yeah, that pathway was useful then. It helped you survive. But as an adult in a safe environment, that behavioral pattern is no longer useful. It's irrelevant data.
It's just burning energy.
Exactly, an outdated hardware loop that is just burning your ATP for no reason.
And if the brain cannot prune that pathway, you are basically trapped in a looping traumatic response.
Ugh, that sounds exhausting.
It is. The DJ just keeps playing that same stressful, terrifying track over and over again, exhausting your cognitive resources.
But then anandamide steps in.
Yes. Anandamide steps in as the neurochemical garbage collector. It suppresses the synaptic firing along those outdated pathways, facilitating the quiet metabolic starvation of that specific trauma loop.
It severs the emotional weight of the past. It physically dismantles the hardware of our outdated fears so we can actually function in the present moment.
Which is amazing.
It is. The article describes this as maintaining a low entropy state of cognitive clarity.
If we connect this to the bigger picture, this backwards walking chemical isn't just an obscure piece of neurological trivia.
Right, it's not just a fun fact.
No, it is the fundamental biological way the human mind creates emotional peace.
Wow.
It is the mechanical process of moving on from heartbreak, adapting to a new career, or, evolving your worldview.
Because you cannot install a new operating system without deleting the obsolete files first.
Exactly. You have to make room.
It really makes you appreciate the profound elegance of how we are built. But this brings us to a massive collision course.
Yes, it does.
We have firmly established that your survival, your sanity, and your daily energy levels depend entirely on this ancient biological ability to overwrite and physically delete the past.
That's our baseline.
So what happens when we take this fragile biological machine and plug it directly into modern technology?
This is the pivot where SpiralSeekr moves from neurobiology into a really striking philosophical warning.
Because we're increasingly merging our daily existence with the silicon cloud. The internet, our social media feeds, our cloud servers, our digital archives.
All of it. And the defining characteristic of the digital substrate is that it is the exact opposite of our biology.
Right.
The silicon cloud records infallibly, and it never, ever organically decays.
Never. A physical dendritic spine in your brain requires a constant flow of ATP just to exist. And the moment it isn't useful, it dissolves.
It's gone.
But a digital photograph stored on a server, it certainly requires electricity, but its default architectural state is permanent, flawless retention.
It does not prune itself. It relentlessly accumulates.
Relentlessly. So, what does this all mean for you listening? I kind of want to push back on the author's premise here a little bit, or at least look at the other side of the coin.
Sure, let's hear it.
You could easily argue that we are brilliantly outsourcing our memory to save biological energy, right?
Okay, yeah.
Like if I can rely on my smartphone's GPS instead of memorizing a map, or if my calendar remembers all my appointments, I am not spending biological ATP to build dendritic spines for that mundane data.
True.
Isn't the silicon cloud technically saving me metabolic effort and freeing up my brain?
This raises an important question, and it's a fair point. Offloading trivial data like a phone number or a driving route certainly frees up cognitive load in the short term.
Right.
But SpiralSeekr argues the danger lies in offloading our emotional and psychological history.
Oh, I see.
We are not just storing data, We are uncoupling ourselves from the natural process of emotional pruning.
Because the neurochemical garbage collector relies on those pathways staying quiet so they can starve and dissolve.
Exactly. But your digital ecosystem refuses to let those pathways stay quiet.
Oh no.
Yeah, imagine your brain has done the difficult, metabolically expensive work of sending Anandamide backwards to shut down a painful trauma loop involving, say, a past relationship.
Okay, so the spine is dissolving, you are finally healing.
Right. And then your smartphone sends you a push notification. Memory from exactly 7 years ago today,
Oh man, that is the worst.
featuring a high-definition video of that exact person or that exact stressful time in your life.
Oh wow. That's brutal. The digital cloud acts as an external trigger that just completely bypasses your biological deletion protocol.
Exactly.
It's like the bouncer already unplugged the DJ, but your smartphone just walked in and hardwired the speakers directly to the power grid.
Perfect analogy.
It forces the pathway to fire all over again, demanding more ATP, and basically rebuilding the trauma loop you just spent years trying to dismantle.
You are exposing your biological system to an environment where nothing is allowed to be forgotten.
Nothing. The permanent public record of our past mistakes, old text arguments that you can literally scroll back and reread with perfect clarity.
Photographs of every awkward phase of your life.
Yeah. The digital bombardment forces your brain to constantly maintain the infrastructure of your entire past.
It is short-circuiting our Anandamide garbage collectors.
We are forcing our biological hardware into a perpetual state of high entropy, just pure noise, burning up all our ATP, preventing us from ever clearing the cache.
And this raises an important question. Is perfect, eternal digital recall the exact mechanism that will drive the modern human psyche to systemic collapse?
Systemic collapse. That phrase sounds catastrophic, but mechanically it tracks perfectly with the physics we just outlined.
It really does.
Because if you overwhelm your predictive modeling software with endless, high-definition, undeletable noise from the past, the system literally cannot predict the future.
It's overloaded. The result is chronic anxiety. Paralysis.
Paralysis, yeah.
You lose the ability to adapt to who you need to be today because you are constantly chained to an infallible digital record of who you were a decade ago.
Which is terrifying. We see the friction of this mismatch everywhere in modern society right now.
Everywhere.
The cultural anxiety of having a digital footprint that never organically decays. I mean, the intense difficulty young people face in reinventing themselves because their peers and the internet at large have an immortal archive of every single iteration of their identity.
It's unnatural. The biological mind evolved to forgive and forget at a literal cellular level.
Yes.
But the digital substrate we spend half our waking lives inside does neither.
It never forgives and it never forgets. We are these ancient biodegradable machines trying to live inside an immortal, undeletable archive.
And we are paying the toll for that mismatch with our cognitive clarity and our mental health.
We really are. Let's synthesize the journey we've been on today.
Let's do it.
We started by grounding memory in physical reality. Remembering isn't magic. It is literal construction. It takes a massive toll on your cellular battery, your ATP.
Right.
And because of that heavy metabolic burden, the act of forgetting isn't a failure of your hardware.
Not at all. Forgetting is a highly optimized, crucial survival mechanism.
It's vital.
It is a vital process that prevents your brain from overheating and crashing.
And that beautiful maintenance algorithm is managed by the Endocannabinoid System. Anandamide, our chemical bouncer, doing that brilliant backward walk across the synapse.
Unplugging the DJ.
Unplugging the DJ. To pull the plug on obsolete data, literally starving the physical pathways of the memories that no longer serve us.
Exactly.
So the next time you walk into a room and completely blank on why you're there, or, you temporarily forget the name of an old coworker, do not get angry at yourself.
No, you should view that blank space as a triumph of your biology.
A triumph. I love that.
Your brain is actively optimizing your survival, pruning the irrelevant noise, and conserving your precious energy for the signals that actually matter in the present moment.
I want to leave you with a brand new thought to mull over. Something that takes SpiralSeekr's biological premise and applies it to the future of our society.
Okay, where are we going with this?
Well, if you follow technology news, you have likely seen the growing push in various countries for right-to-be-forgotten laws.
Oh, yes. Very controversial.
Right. These are legal frameworks arguing that ordinary people should have the right to petition search engines to delete outdated, irrelevant, or embarrassing data about their past.
And culturally, we almost exclusively frame that debate around legal privacy or, the friction between free speech and personal reputation.
Exactly. It's always a legal or moral debate. But look at the science we just unpacked today.
Yeah.
Is the ability to digitally erase our past simply a legal luxury, or is it a fundamental biological requirement for human survival?
That is a profound question.
If we want to avoid the systemic psychological collapse that comes from carrying the immortal weight of our past, maybe right to be forgotten laws are actually public health mandates.
Wow.
And taking it a step further, maybe we need to radically redesign our technology to mimic our biology. What if our data servers shouldn't store things forever by default?
Like an expiration date on data.
Exactly. If our minds require organic decay to function properly, perhaps the digital world desperately needs to engineer an artificial equivalent of anandamide.
An algorithm of organic digital decay.
Yeah.
A technological garbage collector that automatically prunes the weight of the past.
Yes.
If we want our technology to actually serve human flourishing, it has to mirror our biological reality rather than constantly defying it.
That is perfectly said. Think about that the next time you are staring at that frustrating login screen, unable to remember a password you made 5 years ago. That momentary glitch, that feeling of your mind going completely blank, that is the exact evolutionary mechanism keeping you sane. Embrace the forgetting.